Hello everyone! Today we are going to learn how to create and simulate cloth with Vellum. We are going to explore the same workflow as Marvelous Designer, and you will see it is pretty simple to create cloth in Houdini. So let's start! Okay, let's start our project. I have a simple GeoNode here with two agent nodes, okay, a T-pose and a walk cycle. Those FBX I've downloaded from Mixamo. Here is the simple T-pose. I switch the input to FBX and load my FBX file. And on walk cycle, I have a simple walk cycle in place. Okay, everything from Mixamo. And I have, as you see, two outputs. Here on walk cycle, I have a transform and a null to null the output from my walk cycle. My transform has a simple keyframe, two keyframes on translate on Z axis. So I have my walk cycle here, okay. And on this first null, I have my mesh in place, okay. I'm using a time shift to freeze my animation from walk cycle, and I have an S blend, the sequence blend between these two agents. I'm using this and not a switch, so I can show you that we can morph between animations, between FBX animations. Maybe you need this for like linking a few animations on your project, so you can use a sequence blade to morph between FBX files, okay? Right now I'm just using this to show you. I could do the same with a switch function. So on input plane on 0, I have my T-pose in place, and in 1, I have my walk cycle in place without animation because of the time shift. Okay, so let's go to our purpose of this tutorial, and let's place a GeoNode, and call it cloth. Okay, let's start making our cloth. So we are going to use Marvelous Designer knowledge to do this. First, let's make two sides. Okay, I have my perspective, and here I want my front for now. So we are going to use to create cloth like you do on Marvelous Designer. We are going to create a few forms and then stitch them together to make a cloth. To do that, we have this node called patch, planar patch. It creates a simple figure, surface, let's call it like that. And as you see, it has divisions. And for the cloth, this subdivision, this topology is better for cloth. If you see on Marvelous Designer, they work pretty like this. And on this node, you have a few options. Here on build plane, you can switch the plane of your surface, like this is on the floor. We have dimensions. This is like the shape of your surface. You have rectangle, trapezoid, circle, and ring. We are going to create a few different types of cloth, and we are going to use only planar patch. Okay, we are going to create a belt, a skirt, and a coat or over top cloth. We are going to use the rectangle for the belt, trapezoid for the skirt, and a ring for the coat or over top. If you want, like you do on Marvelous Designer, you can draw a curve. If you draw a curve, maybe you can come here and draw your curve like that. Pretty cool. Let's close our curve. Okay, and I want NURBS. Okay, like that. And you can use a planar patch from curves. Okay, as you see, it makes the right topology for your cloth. This is one way to create your cloth, but this is an intro tutorial, so we are going to use only the planar patch because I want to show you that you can do pretty cool stuff with a simple planar patch and changing this shape. Okay, so let's start by making our belt. We are going to start by creating the front belt. Okay, we are going to use a rectangle, and I want a pretty thin, maybe 0.05 y. Let's bring this up, and I want to change the dimensions. If you hold down the shift button, you can redimension on both sides, like on the by the origin. Okay, as you can see, my model is not on center, so let's make this, let's place it like that. Maybe this is way too big for a belt. Okay, and I want this a little bit smaller, something like that. We can go back and adjust this the way we want. Okay, we have our front belt, something here. Okay, and now I want to make the back. Okay, we could just come here and make back belt, but I don't like this way because in the future, along the process, if we need to change the size of our belt, you'll see the back belt won't change because it's not linked with the previous planar patch. So instead of copying this planar patch, let's place a simple transform. This way we are kind of creating a semi-procedural workflow. Okay, so let's call it transform to back, just to name everything. So we have our back plane, back belt in position, and let's merge this. Okay, we have the front belt and the back belt. Okay, as you see, we have everything in place. So now, how do we stitch everything? Like you do on Marvelous Design, you select this edge and link to the other edge. How do we do this on Houdini? It's the same principle, but here Houdini works with the groups, point groups. Lucky for us, Planar Patch has that to help us. On Sims, first I want to, I'm sorry to keep jumping from stuff, because I'm watching and I can see our belt has really low resolution. To increase this, we can go to edge length and let's decrease to 0.01. As you see, now we have more subdivisions. Back to our stitching. How do we connect our pieces as cloth? First, we need to group the seams we want, the edge we want to connect. So on Planar Patch, we have the seams, and we want to connect the edge, the left to the other left, and the right to the right. So we just check these boxes, left seam and right seam. As you can see on the name, here is the name of that group. We are using the name of our node, front belt underscore left, and here front belt underscore right. If we check the information here on our node, you can see now we have 2 point groups, front belt left, front belt right. But when we transform, if we check here, we still have the 2 point groups that we need, but the name are the same, and this is the back belt. How do we change the group names? Easy, let's place a group rename. And instead of picking this one and then copy paste and changing it to back, and do this again to the back, to the right one, instead of doing this, we can simply go here and front, how do you call this in English? Asterisk? Star? I don't know. So let's place front and this symbol, and back here. If we check now, the front, our group names now are called back belt left and back belt right. This way we are just changing the word from front to back. Okay, now if we check on merge, we have 4 point groups, back belt and front belt. Okay, now how do we stitch this? We convert this to cloth, right? Vellum configure cloth. Okay, it's making the constraints for the cloth and everything. I'm going to reduce the resolution or increase the edge length just to the purpose of this tutorial. Okay, we are going to increase the resolution in the future. For now, we have a vellum cloth, and if we make a vellum solver, we are just going to simulate this cloth. Okay, I'm on frame 60, so that's why my computer is freezing. Okay, if we place a vellum solver, these 2 planar paths will behave like cloth and will just fall down with the gravity. Instead of using the solver is just for the simulation of our cloth. We don't want that for now. We want to stitch our cloth. So let's place a vellum drape. This node will allow us to stitch our cloth. Okay, if we go on the vellum cloth, we are jumping this because we don't need to check this for now, just in case you want to have a different fabric and behavior for your cloth. But for now we just want to stitch them together. So let's go to vellum drape. We have load from this. We are going to check this in a bit. But to stitch them together, let's go to drape, draping, and weld additional seams. Check this box and you'll see a new options will appear. You have weld properties and weld seams. As you see now, it is asking for 2 groups to know what to stitch. So as we name this, it's pretty simple. We want to link the front belt left to the back belt left. Okay, and we want another one. So each seam, as you can see here, from the belt left to the back belt left, it's creating these stitches or welds. Okay, so let's do the same for this side. Instead of adding here the back belt, front belt right and back belt right, instead of doing this is working for now, but it's not the right way to do this, because you can have a pretty complex cloth. Right now the belt is really simple to start with. So instead of adding here the groups, let's add a new seam. Just press the plus button, and now let's use the front belt right and back belt, right. Okay, pretty cool. And now, maybe this is only using 2 points, but let me just check one thing. If we do this, okay, now we have 3 points. It's better for the stitching. Okay, now if we press play, you'll see that our cloth will fall down, and try to stitch it. Cool, pretty cool, but as you can see, our cloth is inside the model, right? How can we make the model to collide with the cloth or backside? Let's place an object merge, and let's call it static model. Remember, we use this null, the other 2 nulls, the moving female and static female. To make our cloth first, before the animation, let's use the static female. Okay, and wire this in to our 3rd input of vellum cloth. if you check here, let me hide everything. Okay, something is wrong. I'm importing the object. Oh, I forgot. Yeah. Because we are using agents, we need to do one little thing. We need to convert this to polygons. Okay, and do the same to the next one. Okay, now we have polygons. Right now, if everything goes all right, we can see the collision mesh. Okay. So, one thing I can see is that our cloth is intersecting that arm. I think it's not a problem, but we can just move a little bit to the side. Okay, let's stitch our belt. And as you can see, our belt is way too wide for the body, but as you can see, it is behaving, and we stitch our cloth. Pretty simple, right? Let's decrease a little bit the side. Let me just maybe this, just to see our body. Let's decrease this a little bit, make it on the side. Okay, like this, as I said, because we are using a transform. This is like a semi-procedural stuff. So now, if everything goes all right, okay, you can see we have a really nice belt. Okay, now let's make a skirt. Okay, to stitch on the back, to the back of our belt. Okay, to make the skirt, let's place another planar patch. Call it skirt. Okay, let's make a skirt. We want the skirt to be on Z and X plane, and I want to be a trapezoid. On trapezoid is a little different from the rectangle because you can like scale one of the sides. Okay, now we want maybe the top, nope, the bottom. We want the bottom because we want to stitch this like this. Let me check this one to see where is our back plate. Okay, pretty cool. So one way to do this, we want this top side to be the same size as our belt, right? We know we are working with this side. Let me check. Okay. One way to do this is to copy paste this parameter on the width of our rectangle of our belt. Copy parameter and then come here on taper or taper and paste relative reference. This way we know that our skirt will have the same size as our belt. Okay, pretty cool. And then we can play with this. I like to make like a long, really long skirt, like it was a wedding thing. Okay, I want it to be a little bit higher, wider on the width. If we change here to 2 or 3, you can see now that our taper or taper is not the same size as the belt because we increased the width to 2. This is easy to fix. On this vex expression, let's divide by 2. Okay, because we are doubling the size on one, so let's use the half to the taper or taper. Okay, so we have a really nice skirt. And remember, we need a new seam to be able to stitch and weld this top side or bottom, I think it's the bottom, yeah, the bottom side to our back belt. Okay, so let's use the bottom seam. We don't need any more groups. Okay, just this one, and wire this to the merge. Okay, go back to our drape, remember, and let's create a new seam. And on this one we want a new back. We need a new back belt. I was forgetting that. So let's go back to our planner patch, and we need the bottom seam. Okay, so you can have this group. So if everything goes all right, let me turn this off. Okay, on Vellum drape, now we have the back belt bottom. Okay, and we need to wire this to the bottom skirt, skirt underscore bottom. Okay, now you see we have a few problems, right? Because these seams use points to stitch everything together. Okay, so our groups need to have the exact same points from back belt bottom to the bottom skirt. Okay, how do we fix this? One way to do this with a simple planner patch is just to have the same. Oops, sorry, I did one thing wrong. Copy parameter. I was saying one way to do this with the planner patch is just to have the same edge length. That is, my computer is processing because it is making the planner patch, okay, with a higher resolution. We have the same edge length. If now I check my welds, you can see they have the same points numbers. In case you don't want to have this higher resolution for the skirt, we can, let's delete this channel. Okay, think a little bit, my computer. One way to do this is just to check how many points we have in one group and have the same for the other. Let's increase this. Again, if we check Vellum drape, we don't have enough points to wire this. So one way to do that is, if I remember, here on the point groups, on the information from this patch node, you can see our front belt bottom has 40 points, okay? And in our skirt, we have only 9. How do we increase this without increasing the resolution? You can come here to our planner patch from the skirt, and you can see we have an option down or below the bottom seam, okay? You can put bottom points, and here you can increase the number of points you need. You can see now we have a lot of points here without changing the resolution from the planner patch. If you now check the Vellum drape, you can see we have all the points connected. One thing I want to show you is that sometimes, imagine this planner patch was flipped, something like this. I think I can do. I'm going to place a transform just to show you what I want to see. If I rotate this, not that one. Okay, sorry, just checking this out. Here, 180. I want just to show you one little thing. Zero. Okay, let's place our skirt in the right position. Okay, Imagine our skirt was flipped. Okay. Now you'll see that when we wire everything with the drape, our stitches, our seams are flipped. Sometimes these happen when you rotate your planer patch and something like that. And don't be afraid, because we have a few options here on the Vellum drape. We can reverse. This will fix our problem. And sometimes you can cycle your seams. Okay. Right now the cycle is okay, but as you can see, if we still have problems, you could just fix the cycle, because it is using the point order, and sometimes the point order is not correct. Okay. In our case, everything is all right. Let's go back to our making our skirt on the right position. Okay, let's move this up. Okay, just a little thing. I'm going to turn off this preview. Okay, so now if I press play, everything will stitch. Pretty cool. Collide with our body and our skirt will fall down. Cool. But we need just one thing. We need to add a floor, because if we let this simulation go forward, you can see that our skirt will cross our floor. Okay. Let me just wait a little bit, because we don't have any collisions for the floor on the Vellum. Okay, we are just using the female. Okay, so this is a problem. We need to fix this. It's easy. Just place a grid. Okay, now we have a floor. I know there is a problem with Mixamo. As you can see, our feet is not on the floor. So let's place a transform. Let's wire this in, and let's dial this down a little, like this. Copy paste this node here, and everything is all right. Okay, now we need to add the grid to our cloth simulation. Let's go back to grid. Okay, it's polygons. Let's increase. I don't think we need to increase the resolution, but okay. So let's go back to our cloth. Do the same as we did for the female. Let's call it floor. And instead of merging the female, we want to merge our floor. It's the grid. Okay. Now if we need to merge everything, we need to merge the static female and the floor to the merge, and instead of wiring the static model, we are going to wire the merge to the third input of our Vellum. If you see now we have the blue wire for the floor. If we let this play, you'll see that our skirt will now collide with our floor. Okay, pretty simple, right? And now we just need to make our top coat. Let's go back. Something went wrong. Let me save this before I lose everything. Intro Vellum tut. Okay. Sorry. Okay, now let's create the overtop for our coat for our mesh. Let's use again a planer patch. I need to see my model. Okay, I want to be this on Z and X, and on shape we are going to use ring. Okay, we don't want an open arc, we want a closed arc. But if we, I don't know why, but if we increase this to 360 angle, you see that our planar patch is now closed. It's not a ring, we don't have a hole inside. I kind of understand why, because this is using a curve. So by closing this curve, it is making a surface. It's like we have a circle nerve. So instead of using 360 degrees, we are going to use 355. Okay, so we have a nice little ring with an open space here. Don't mind about that, because we can simply weld and use these as seams. Okay, so let's place this in the right position we want. Okay, let's decrease this to 0.1, 0.1. I'm going to increase the resolution, decrease the edge length. Okay, maybe this is way too low. Okay, you can see here a little hole. Maybe I'm going to change this to the top viewport so we can see where are we placing our hole. Okay, just around the neck, something like that. Super easy. Okay, I think everything is all right. Let me decrease this a bit. Okay, that's good for now. And let's make this size bigger. Maybe 3. Okay, I think this is a really nice cut, like an umbrella. So again, let's go to planar patch. We know we need to seam and we'll stitch these sides. So let's go to left seam and right seam. And I want to call it coat. Okay, let's merge the coat, wire the coat to the merge. And now we need to stitch this. A new group, let's go to drape, seam, new group, new seam, and let's go to coat left and coat right. As you can see, I was mentioned this before, our seams are wrong, they are inverse, so let's check this reverse checkbox. Now everything is correct. Pretty cool, and let's play our simulation. Everything will fall down. Let me wait a little bit. I think this is cool. Okay, so now we have our skirt, our belt, and our coat. Pretty cool. Now, how do we use this on a cloth simulation? Okay, if we wire this to a Vellum solver, it will work, but I want to show you a little process before. Okay, first we need to freeze this animation. If we freeze this on 150, let's change this freeze at frame 150, you see that we will freeze the simulation. So right now we are always using this freeze frame at 150. I'm using a higher number because the cloth simulation was taking a little bit to simulate and fall down. Okay. One thing I like to do is save to disk and load from disk, just in case we don't change anything and it's loading from the disk and it is faster. Okay, right now we won't lose any anything. Okay, so we have our cloth. We need to do a few things first before our simulation, just in case to prevent from this to explode. So let's place a Vellum Postprocess and wire only the first input. If we do this, we can see we have apply welds. This is doing one thing that we really need. Let me see if I can show you here. Okay, I'm going to turn on the points, trying to find out where they are. I was looking for the seam on our code, but I kind of missed it. Let me see on the belt. Okay. Here on Vellum drape, we use the seams to stitch these sides, right? But right now we have these points. We have, in this case, on this point here, we have 3 points at the same location. And that's, why is that? Because we have the front belt with a point here, the back belt piece has a point here too, and the skirt has a point here too. By applying the Vellum process, you can see that these points are only one now. We kind of glue everything together and we don't have multiple points on the same position because we are welding every single piece, okay? Like merging and deleting duplicate points. I think if we come here and shake points, and here we have a few less points. You can see 680, and here after the post process we have 604. Okay, we are deleting a few points. Okay, so now our cloth are only like 2 pieces, the coat and the skirt. The belt is weld with the skirt. Okay, we can come here and subdivide. I like to use the loop. If we subdivide, we have more resolution for our simulation, but for now let's keep it on none. You can extrude thickness, okay, but for now we are just editing our cloth for our simulation. One other thing that is wrong, you can see that sometimes our faces are white and others are blue. This is one way to see the normals of our cloth. Okay, if we turn this on, we can see that our coats have the right normals, the skirt too, but if we check the belt, you can see we have a few problems. You can see the back belt, the back belt has the normals wrong, because we are just transforming and not flipping the normals. One way to do this, we have the Poly Doctor. This node can fix everything for us. Well, it's going to recalculate the normals depending on everything. So I think there is great winding polygons. Okay, by checking these out, it is going to check every topology, every model, every polygon, check the normals and fix them to make them uniform. As you can see, check this out on the belt. If we have this turned off, the normals are the wrong side, and if we check this one, it's going to be on the right side. Okay, so now everything is correct, and we can use now this cloth and simulate. So let's place a cloth again. Vellum configure cloth, wire this in to the, let me turn off the normals and go back to single view. I want to see the perspective. Okay, we have the Vellum cloth, and I want to use the collision, same as we did on drape. Not the same, because now we want to animate one. Okay, so let's do something here. Let's import our animated female. Let's go to woman, moving female. Okay, pretty cool. And we need a merge and the floor again. Let's place a merge. Let's wire the floor back to our merge and wire this into the third input of Vellum cloth. And now we want to simulate the cloth, so let's put a Vellum solver. Wire the 3 inputs and we have everything together. We have the cloth, we can see with the blue color are the collisions, and if we press play you'll see that our cloth will simulate and fall down and collide with the body. One thing I want to let you know is one little it's not really a trick, I was calling it a trick, it's more a tip. Always check the thickness. By checking this box you can see the size of our thickness, and this shouldn't be really big. I'm trying to show you the belt. You can see here on the belt they are really big. So let's fix this and go to our Vellum cloth and change the thickness to 0.005. Okay, they are smaller, they are better this way. Okay, so now let's uncheck this and press play. See, now we have our body moving and we have our cloth, they are colliding with everything and they are pretty cool. You can see we have a problem. If you see the hole on our code, it is stretching too much. You can see this is stretching way too much for my taste. One way to fix this is go back to cloth and increase the stiffness, or other way to fix this is just go back to the solver and increase the substeps. Increase this to 5, it will solve our problem, because it is using more substeps each frame to process our cloth, and it is not stretching that much. Because sometimes the default parameters from Vellum cloth are really good for simple cloth. So one way to fix that is just increase the substeps. As you can see, our hole in the coat is not increasing anymore. Okay, pretty cool. We have everything together. So right now, what we can do is place a post-process, Vellum post-process, wire this in. Okay, now we can do a few things, a few post-process that we didn't do on this one, because this is after the final simulation from our cloth. So we can subdivide. I like to use the loop one. It is keeping the same topology. Increase this to 2. Okay, we can detangle, check if any cloth is intersecting each other, and we can extrude and add thickness. Okay, pretty cool. And after this, I like to save everything on file cache. I'm going to do this, I'm going to stop the recording and I'm going to cache this file cache. So right now let me just call it cloth cache. As you may have seen on previous tutorials, I like to delete the $file heap name, because I keep changing the project name. Okay, and same frame range. Everything is alright, and I'm going to stop the recording so I can cache everything. So I'll be right back. Okay, so I've got the file cache done, and I did a simple flipbook to show you the simulation. Pretty simple, yeah, and cool. Now it's up to you to color the cloth. One thing I did on my animation is that I don't have everything on the same Vellum solver. I have a Vellum solver for the coat, another for the skirt. Okay, so that way I could just place an attribute VOP. I think a point VOP could work. Attribute VOP. Let's pick up the points. And I just use a turbulence noise to color our cloth. Just like that. And I increase this and change the amplitude. This way I colored the coat. But for that I had a different solver for only the coat. I had a solver for the skirt and another solver for the coat. Okay, that's it for this tutorial. It was pretty simple. Just one way to create cloth. Now you don't need to go to Marvelous Designer to create simple cloth animation. You can use planar patch, use simple surface. As I said, you can draw a curve and then use a planar patch from curves. It will make the same as this one, but following a curve. Create groups, point groups to be able to use on drape for seams. Okay. Now after that, edit your cloth with Postprocess. Polydoctor in case you need to fix the normals. Then wire back to a Vellum cloth and then use Vellum solver to simulate our cloth. Okay, simple as that. Of course, after that you can paint and use Vellum post-process to subdivide, add thickness and detangle in case you need it. Okay. As you have seen, it is pretty simple to create cloth in Houdini with planar patches and Vellum drape. To simulate, you just add a Vellum solver to the process. This workflow is really similar to Marvelous Designer. Before we finish our video, I want to thank our patrons for the awesome feedback and support. I'm really happy we have reached our second Patreon goal. And this cloth animation will be part of a special movie I'm doing to thank you all. I hope you enjoyed this video, and if you like this tutorial, don't forget to hit the subscribe button and check out our Patreon page. Have a nice day and see you on the next one.